you need your purple page, and I'm going to give you one. Another one. So, we will be writing on the purple page, so you'll likely need it out of the ring.
Solving equations and inequalities.
Solving equations and inequalities, we focused on the equations piece, correct?
Correct.
What was happening in those specific equations we were solving? Distributive property?
Combining like terms.
Pause. Distributive property means to do what operation? Multiply. And were we dealing with one variable or variable on both sides?
Variable on both sides.
Variable on both sides. Okay. And we worked it to where like x equals 13. See? X equals 3. Yes?
X equals
okay. So I'm gonna have you. Oh, nope. I'm still good. Annotate. Where donde está? Found it. Oh, okay. My tabs are still up. I'm glitching right now. Can you tell? Like I was so set and now I'm glitching. Okay. Alright, on your highlight sheet, we're going to look at the first one on the right side. Like, right side of the, right there. So, we're going to draw our line. We'll go green. So we're, oh my gosh. I am now calibrated. Maybe. We're going to draw our line. On the step side, what does step number 1 on our purple page say?
Distribute if needed.
Distribute if needed. Do I have any distributive property to complete?
Yes.
Alright, so I'm going to distribute 1/3. So truly I'm saying 1/3 times 21x, which calculate, hold up. 1/3 times 21. Said that it will. 1/3 times 21. And if you do it mentally, just hold up your calculator either way. Alright, 1/3 of 21 is? 7. Because if you break 21 into 3 groups, it's 7 in each group, and just take one of them, 7. And that variable just hangs along for the ride, correct?
Yes.
1/3 times 18. Hold it up if you know it, hold it up when you have it. So if you have it mentally, just hold it up. If you want to prove it, hold up the calc. 1/3 times 18?
6.
Positive or negative?
Positive.
Okay. And I'm going to bring down this side. So your strand right now should look like so. So remember, I bring it down, I treat it like jemmies, I bring down what I haven't used. Let me ask you this, Gilbert. I'm asking Gilbert, but anyone can respond if Gilbert sees fit. That expression and that expression, are they equivalent?
Yes.
Yes, they're equivalent. This is just the simplified version. It's been simplified. Alright, step 2 on the purple paper. Alright, on this side do I combine?
No.
That side do I combine?
No.
Okay, step 3.
Balance variable.
Balance the variable and coefficient. Well, could I balance either?
Yes.
I typically go for the smaller value. Which one do you want to balance?
6x.
Alright, here's the most important step. Subtract and strike. What you do to one side?
You do to the other.
And then I draw my line telling you what to bring down. So I've canceled out 6x and I bring down -3, correct?
Yep.
And on this side, 7 minus 6, I could say 1x, or I could just say x plus 6. we balance variable and coefficient?
Balance
What are we gonna
constant
balance?
to the other- Balance constant to other side.
What am I gonna balance?
6.
6. So I'm gonna cancel it out, so I'm gonna subtract 6. Subtract 6. Lily Gomez! At this point in your life, you're gonna type it in the calculator exactly how you see it. So I would type in -3 minus 6. Exactly how I see it. -3 minus 6, Taylor? -9. I spooked you, you weren't expecting that one. So I rounded out to say 1x equals -9. Is that synonymous with saying x equals -9? Is it the same? Yes. Alright. So we're saying when I plug in the value of x, I will get, or when I plug in 9, it'll be a true statement, right? Only value that can be plugged in to make this true is what? -9. You followed my lead method wrong. Alright, I want you to hop to the white paper I gave you. Alright, up toward the top of the page. I would like you to work this one with your partner. Point to me. Stop writing. Sit, Morgan. Stop when you get stuck. Thank you, bye.
Do we do that one or don't?
Okay, -6, okay.
Oh, yeah. So it's 8x.
I think I combined, like, I combined 8 and 8x -5.
The other side is 5. What's the other step? Combine like so -5x. 8.
Lily, are you working with them? Bow out.
Let's just subtract 3x. Which one?
I am living for your conversation.
Yeah, that is 3.
Yeah. That would be
3x
So I think you just do it like that. I think 8
equals 5. They don't matter.
Yeah, add 6.
Minus 3.
So that's 11.
I'm just kidding. You have 11.
Stop when you get stuck.
Okay.
Wait, I balanced out
This is quite confusing. There's a lot of x's. Yeah.
I think that's right? Because if you would drop the 1 down, you know that has a visible
No, x is just a number. You added 1.
minus 0. If it was minus 2, that would be equal to 11, right? So, where am I getting 11 from?
I don't know.
Okay, yeah, no, I
I did 1.
I think that this goes.
You can't do that. Should stop you.
Alright, back to me whether you're done or not. Put your pencils down. Don't you hate it when I stop you if you're in a problem? Just like see your phone. Alright, here's what I want you to do. Strike this problem out. Box this, put a box. Whole thing. Like not all of your work, just what was typed on the page. Just how I have it. Draw an arrow. So what I had you do is I had you work it. You're gonna work it with me in that space now. Alright, so we're gonna have different, we're gonna work the same thing just in a different spot. You feel me? So to work it, I'm gonna rewrite it.
I need Emma Martin. She's leaving.
give me a look when you're done writing. I don't want to move on without you. Decided to keep the shorter one because Jean's the shorter Jean. I FaceTimed my best friend and she said shorter ones. Okay, draw my line. Alright, what did y'all start with? Distribute. You distributed that 2. So 2 times 4x will give me 8x. 2 times negative 3 gives me negative 6. Minus 5x because I bring down what I haven't used. And I'm going to bring down on the other side also what I haven't used. Alright. Boom! Emmy sees that we can combine our like terms. Do y'all agree with her? Alright, so like terms being same variable to the same power. So I'm going to circle 8x. And I'm going to circle the negative with that 5x. I take the sign that's in front of the term. Okay? So now I have 8 minus 5 to give me 3x. Minus 6 to bring down. And on this side I equally have 3x plus 5. Did y'all get to this part pretty well?
Yeah.
So now my step 3 on purple says to not y'all balance the variable. Which 3 do you want to balance?
Left one. Because you have bias there.
The left one.
Juliana and Elijah, rock, paper, scissors. Left one. So, watch me. I'm subtracting 3. That's the most important step. What do you do to one side?
You do the other.
Now let me ask you this. Do that and then put your pencils down. Alright. If I have $3 and for some reason I owe Kaylee Grogan $3 and I pay her, how much do I have left? 0. Okay. If I have $3 and I owe Jace $3 and I pay him, what do I have left? 0. Do you remember if you have 0 over 5, do I want you to show that fraction?
No.
If I have nothing left, do you show it?
No.
If I have $3 and I owe Taylor $3, do I have any money left?
No.
I have 0. I have zilch. I have nothing to show. So essentially at this step, my variables completely cancel out. I don't bring an x down at all. Where on the flip side, if I had 3x divided by 3x, 3 divided by 3 is 1. But that's not the case here. I have 3, I take 3 away, I'm left with, I don't represent. Okay, my variables cancel out at this point. So if I bring down what's left, that's why that stripe process is so important. I'm going to bring down 5 equals negative 6. Emmy says, is 5 equals negative 6 a true statement?
No.
It's a false statement, correct? It doesn't say x equals 5 or x equals negative 6. It's just outright a false statement. Do you agree? What I would call this is a no solution. Up until now, you have worked in the realm where when we solve equations, x will always equal out to a rational number of some sort. Okay, a real number of some sort. Right now, we're going into another world like Little Mermaid. We're in a world where x won't necessarily equal out to a value. This tells me no matter what number I plug in for x, it will always make a false statement. Always and forever. Okay? So let's test it. What I want you to do is you're going to take your paper and you're going to do Grigsby fold. So where we still see the problem that we're going to work, but we have enough room to work it down here. Alright? So you're going to fold about halfway up. So I'm saying if your equation boils down to a false statement with no variable there, your variables canceled out completely, it's going to be a no solution, meaning no number that I ever plug in will ever make a true statement in that type of equation. So, on the folded piece, on the what piece? Folded. We're going to rewrite it again. You're just going to love this problem by the end of the day. Or have it memorized and hate it. Alrighty, Aiden. Choose a number between 2 and 9. 7. So is we're gonna plug in 7 to see if the no solution thing is a fake out or if it's a real thing. Alright? So he just told me a number, I did 2 and 7, or 2 to 9 because I don't want to go double digit when multiplying. So we're gonna say x equals 7. Therefore, anywhere that there's an x in this problem, I am substituting what value? 7. So I'm going to rewrite it with substitutions. I'm going to say 3 parentheses 7 plus 5 equals 2 parentheses 4, ooh, double parentheses, minus 3, 5 parentheses 7. This looks silly. What a strand. What a silly goose. Alright, and truly, I'm going to do my balance, but I'm going to do gems on each side. So I would multiply to get 21 plus 5. So I'm not following those equation rules right now, I'm following gems rules. Alright, because I have a value plugged in at this point. I'm following gems. So I got to solve in the groupings first. So I'm going to say 2 parentheses 28 minus 3, and then negative 5 times 7 is negative 5 times 7?
35.
Negative 35. Alright, here's what I'm going to have you do. Do you see how I've gotten to this point so far?
Yep.
Okay. That's 26. Would you agree?
Yep.
Alright, type this in your calculator exactly how you see it. We'll take the top out right now. Hold it up. You're going to type that second strand in, 2 parentheses 28 minus 3, parentheses minus 35. Bless you. How you see it. And hold it up when you have it. No, just in the calculate part. What do you get? 15? Alright, looking at this. 26 equals 15.
No.
It's a true statement or a false statement?
False.
Therefore it has what? No solution. So we just proved this is a problem that no matter the number I plug in, it will have no solution. Number doesn't matter. Alrighty? Yes. So as Jaslyn said, if I get to this point and I'm like, that's a very false statement, you could put the strike through the equal because we know that represents not true statement. Alrighty. So are you ready? Okay. Glitch. I would like for you to do that one with your person. Stop when you get stuck. If you get stuck, you might not.
Now our first one is so do we have anything that lines to
Yes.
Oh my gosh,
It takes literally the process.
I have so many hiccups right
So
now.
we do 2 times 4.
Hiccups on what slice?
Okay. Then we do 2 times negative 1 equals negative 2 plus 1. Then we drop down to the next one is combining.
Let's do this one.
Negative 12.
Oh my gosh, I can't do that.
Yes, you can.
So I mean, I can't do it. I can solution.
It is. Okay. Sine.
Yeah.
So negative 2. You get 7.
Are you leading or condescending? You like He's leading. Okay.
I'm leading.
Okay.
I don't know what condescending means, so.
Wait, what's that?
Oh,
I should have clapped him.
yeah.
Oh my gosh. Think about time, distance,
It's the same on both.
but the sun to the earth is, I don't think is 8 minutes. So that could be different. So it could be a line from a baseball to 6 minutes.
That is both. Now, 7. It's blue.
Yes, 77.
No, it could be a zero. It's fine. You saw it started. Bro, that's pretty bad. No, you could have been on.
There was no season, actually.
Yeah, there was. She was on it.
You're talking about ball?
Basketball.
Yeah, that's.
We could have specified. But there's no way you missed that close.
Brother, you see there's nothing in it. There's no way to
The ad
bring it
way.
to where it's
The
going.
ad way.
Alright, back to
So just
me.
not know all the.
Alright, so I'm going to work it in the same space. If you did something differently than me, you can correct it. I imagine we're going to have pretty much the same steps this time. Alright, you distributed first, yes?
Yes.
Alright, so 2 would be 6x and -2, and I bring down what I haven't used, correct? When I distribute, it drops those parentheses. That's my goal. You may open. So on this side, I bring down what I have not used. Now, step 2 on your purple paper says to do, well, combine like terms. Do I have like terms on this side to combine?
Yes.
Okay. -2 plus 9 be +7. Do I have like terms on this side to combine? Okay. What do you notice?
They're the same.
Same on both sides. Were they the same on both sides in the other problem?
No.
No, so this is a different type, right? Alright, I'm going to follow out my steps. I'm going to balance my variable. Do you want to balance this 6 or do you want to balance this 6?
That 6 on the left.
On the
We
left.
went left, we're going to go right. Because does it matter?
No.
It does not. But my most important step is striking out that 6x, showing that I've canceled it out. So I bring down what I haven't used, correct? What have I not used from this side? What have I not used from this side?
So technically it does have, well not, I
Is
don't know.
this a true statement or a false statement?
I mean, it's
True statement. Kylie Benson, what is it?
Infinite solution.
We would classify this as an infinite solution.
How did you know that, Kylie? Because she had to get tutoring.
Infinite solution. That's why I sounded it out. Infinite solution. So, as Jaslyn is saying right meow, I could plug in any number for x. If I plug in 13 for every x, I will make a true statement no matter what. I can plug in 1,426 on both x's, and it will boil down to a true statement. Do you want to prove it? Do you want to see it in real life? You don't, but you think we will? Yeah? Yes, sir? You want to do 8? Alright, if you still have room on your folded section, we're going to work this on your folded section, which means I'm going to make you rewrite it.
Yay.
Thank you for your enthusiasm. It means so much to me. And we're going to say x equals 8. That was Eli's pick. Instead of me going through this with you, no, I will, because I'll take shortcuts. I'll take shortcuts for you. So if I'm saying x is equal to 8, that means what am I plugging in for every x value? 8. So first I got to rewrite it with that value. So I'm not necessarily at this point following equation steps because I don't have a variable to isolate. When I have full numbers, I'm following Jim's steps. What's that face for, Amy? Did I do something wrong? Oh, not me. Alright, so I would solve within the groupings first. So I'd say 2 parentheses 24 minus 1 parentheses plus 9. Because the parentheses only drop when we do what?
When you solve it out.
When we would distribute, okay?
Oh, yeah.
Those parentheses only drop when we were to distribute it, alright? On this side we have 48 plus 7. So, 48 plus 7 is going to equal out to 55. And then you can go ahead and type that in your calculator and hold it up. We'll take shortcuts. Bless you. Y'all are some sneezy folks today. I do. Paisley, what'd you get? Oh, yes. Alright, did y'all get 55 also?
Yeah.
Oh my gosh, so you're telling me I plugged in a different number other than 7 and I still rounded out to a true statement? Infinite solutions means it will make a true statement and it does not matter what you plug in, it will always boil down to a true statement. Alright, get your purple page.
Do you put this in a line?
We will when we're done. We're still going to work over the second. Where's my mouse? Found it. Okay, so we're going to write, so we had a no solution where it makes a false statement. We had an infinite solution, meaning it will always make a true statement. What do you think it's called, what we were doing, where x equals 13? X equals 3. What do you think that was? One solution. Because no matter what, x will only ever equal one number. One number is true. So we're going to write those 3 things in this box. If you run out of room, we can use this extra space. Me, I'm going to run out of room. So I'm going to start one solution over here. However you want to write it. Alright. So, one solution balances to x equals 1 value. So it's going to balance down to a variable equaling out a constant every time. And that constant is the only value that can be plugged in to make it true. So it will balance to x equals that one specific value. Then we had no solution. So what was happening in no solution? Maybe what kind of statement?
There could
False.
never be.
And look at the one we did together under the number 1 slot on the paper. So like this one we drew the arrow out to, the one we did together. What do you notice when we got down to the bottom? What was happening?
Positive 5 equals
The sum of the numbers were the same, right? Were both of them the same? So in a no solution, your variables cancel. Your constants are different. That was the piece. Your constants were different. Meaning it's a false statement. So our variable and coefficients balanced out. They canceled out in a no solution. It's the constants being different that made it a false statement. And then with infinite solutions, infinite, my hunger just hit, which we would also call real numbers, all real numbers, okay? Because any real number could be plugged in. So you could see it phrased both ways, all real numbers or infinite solutions, because any real number could make it true. So with infinite solutions, what was happening in those infinite solutions?
any real number.
But what, in the process of our work, what did you notice in the process of that work? The constants were the same, so variables canceled out and constants were the same. And when our constants were the same on each side, that's what made it that true statement. So that's the twist we're going with variables on both sides. If it's x equals a value, it's going to be one solution. That value can be plugged in to make it true. If my variables cancel out and I have different constants on either side, no solution. No value can be plugged in to make that equation a true statement. Infinite solutions. Constants or variables cancel out. Constants are the exact same, and that's that piece where your constants make that true. Yeah?
Yeah.
Unfold your paper. I still got 8 minutes. Do that middle one with your husband. Get your life together, Macy. Ooh. Put him on the spot. He's for 2 wrong.
Okay, so then I need to combine that is 3x and 5x. 5x minus 12 minus 5x.
So, this is one of the fancy ones we learned about today, so do it on
I'll give you a little bit and then we're going to come back together with it.
So we have the no solution. So we have to write out.
My class one, you do this.
Okay.
Oh, wait. My brain just stopped raining.
Okay.
Next. Minus 12. 5x.
Stop what?
That's not because that's the one with the less value. Anyway.
Alright. I'm taking a lap and then I'm going to walk.
4x.
Abby, stop it.
And then you drop everything down. Sorry. How about you sit down? Anyway,
back to me. Sorry to steal your thunder. Alrighty. Do I have something to distribute? Yes.
Yes.
Distribute. The goal is to get rid of those parentheses, and the only way to do that is to distribute. Alright? So, when I distribute to both, I'm going to get 3x minus 12 plus 2x. Bring down over here, 5x minus 9. Does your strand match with mine?
Yes.
Okay. At this step, I would combine like terms. Do I have like terms to combine?
Yes. 3x
Okay.
and 2x.
And I circle the operation in front of that term, so that 2 will be positive. So 3x plus 2x gives me 5x minus 12 equals 5x minus 9. What do you notice besides that really cute x?
Oh, are the same.
My variables are the same. Are my constants the same?
No.
What can you pick up from that piece?
There are no solutions.
Alright, let's prove it to balance. Subtract 5x and strike. What you do to one side? And strike. Now I'm going to bring down what I have left. What's left on this side?
negative 12.
What's left on this side?
-9.
Is it true that negative 12 is equal to negative 9?
No.
So that is a false statement, meaning it is no solution. No value can be plugged into this equation to make a true statement. So I'd label no solution. Make sure you're balancing those variables first. Alright. I'll let you go to this one and you can substitute and put an x in place of the q. Q if you would like, because Q's can sometimes look like 9s or 4s.
Okay.
So rock and roll with that one.
I was not a good teacher last time. I'd be better. It's rock down the line. That's what we need to do. Minus.
Then, okay, our first step.
Well, our first step is a good job. That's 5 times 12. That's 3 meg x would be x because x is 1. We do what happens. Multiply. Mega 12. On this side, we don't have anything. So just drop it down. 2
Don't have a microphone.
Good job. I said it. You draw a line. You draw a line right here. Now we can do this. Sideways, we have to bounce
Oh, I know why.
on the right.
Yeah, you're right.
Minus 2x. Because that one's talking. That's from x. Now the other side, that's
Yes, ma'am.
now we do the left.
It is nudge. Yeah, I was gonna say 5 minutes will be here. Alright, fine.
Yes. Good job,
Not me. Alright, so this one, what did it boil down to?
20.
So x equals 20?
Yes.
Your variables did not cancel out. Therefore it is a one solution. So you boiled it down. X is 20. When a variable and a constant are balanced to opposite sides, are able to be balanced to opposite sides, I would call it a one solution. Alright, got 3 minutes. Here's what I want you to do. Pause. Listen. Alright, here's how I set up our notes. Here's how I like your binder to be set up. Alright, here's the paper from the other day, right? It's already in the rings, correct?
Correct.
Alright, don't take it out. You're going to put today's paper on top of that. So every new page stacks, and then the unit that is related to goes to the very front. So, yesterday, today, purple. Yesterday, or Thursday, today, purple. Alright, I would like that to be in your notes section.
Barnes and unsafe.
You don't give me the fun page. Okay, at least you got it. My bad. Did you call them literary?
I didn't mean to.
You know, back in my day,
I only saw it after you replied.
Also, just note, you're going to miss me when you're gone because my other algebra baby is going to say, you need to come here.
Teaching algebra.
So actually, the path you're going to take forward
So
is likely geometry, then algebra 2.
That's what my sister did.
You get the choice of those upper level pre-cal stats. So you'll actually go to geometry next year, which if you really like algebra, you're going to hate geometry.
I know. Because Holly has one of the algebra teachers, and he goes to our church.
Yeah, I love Mr. Nichols.
I don't remember his last name. He's in Sims or I don't know.
Of course, his middle name is Mr. Nichols.
I don't know if I know. Hey, folks, bye. Have a great lunch. Love you guys. Have a great day. Bye. Bye. Don't forget your phone, Ryder. Oh, yeah, not this time. Haley, don't forget your phone. You left it at home today.
Don't forget mine too.
Goodbye, goodbye.
Mine is grade 3.
Is your folder in the bookshelf or did you take it?
It's in the bookshelf.
Okie dokie. Bye, have a great day.
You too, Miss Grade 3.